All right, hello everybody. Today we're going to move into Chapter 8, Section 4, and it's pretty much a continuation of what we have done in 8.3 and 8.2, in that it's just an application of multiplying polynomials, but it's going to show you more of a regular context of where you will use this in this class and your subsequent math classes. And I think it's important to realize that many times you will see this notation. It's not going to tell you explicitly use the FOIL method or use the box method to multiply. They will just give you an expression like this, and it's going to be understood that you will know how to do this, how to multiply it out, what it means. And so as you can see in this first set of directions here, it just says square of a sum. And what they want you to do is multiply this out. They don't tell you how to multiply it out. You just see this notation and it says this expression, this quantity, is being squared. So what you need to remember is that when you square something, it is multiplying something by itself. So that is what we're actually going to show. I highly encourage you to write this square out. Many times students think that they can take this 2 and multiply it there and just distribute it to the powers of 8c and 4. And unfortunately, that is incorrect. You cannot do that in this instance. And the reason why you can't do this in this instance is because there is a plus, or as you'll see in a second, a minus there. Anytime there is multiple terms inside of an expression that is being taken to a power, you must multiply it out. You cannot distribute the power. This is a very, very, very common mistake that I see with all of my students across the board, that they forget this. So again, coming back to what it means to square something, it means to multiply something by itself. So in this case, we are taking 8c plus 4, and we are multiplying it by 8c plus 4. So we've expanded this expression out based on the power telling us to square it. Now we will proceed to FOIL these together. And as I had said in my previous couple of videos, you can use the box method or you can use the foiling method. My preferred method is FOIL. Most of the time as you move up through your math courses, you will use foiling. So that's what I'm going to use. So we have 8c times 8c, which is 64c squared. Then we have 8c times 4, which gives me 32c. Now that the 8c has been distributed, the 4 needs to be distributed. 4 times 8c is again 32c, and then 4 times 4 is 16. So now that we've had it multiplied out, we will combine our like terms. The like terms in this case are the two 32c's. So the 64c squared gets written first. Then we have 64c. Then we have plus 16. And there's your final answer. Now the next problem is exactly the same. We have an expression, 2t plus 6. It is being squared. So we will write that out, 2t plus 6 times 2t plus 6, just like that. Then we will FOIL. 2t times 2t is 4t squared. 2t times 6 is 12t. Then we have 6 times 2t, which gives me another 12t, and then 6 times 6, which is 36. Now, following FOILing it out, getting everything multiplied out, we will combine our like terms, 12t and 12t. So we get 4t squared plus 24t plus 36. And there's our final answer. Now, we're going to move into what is called a square of a difference. Now, what we did there was called a square of a sum. The reason why it was called a square of a sum is the two terms inside the parentheses were both being added. And so you end up with all positives all the way across whenever you FOIL this out. When you have a square of a difference, we are squaring two terms that are being subtracted. That's what the word difference means. So this turns out a little bit different because of the negatives. So we will start by expanding this just like I showed you before. 6p minus 1 times 6p minus 1. And follow through with the foiling method again. 6p times 6p is 36p squared. Then we have 6p times negative 1, which is negative 6p. Then we have this negative 1. Remember, the sign goes with the number after it. So the negative has to go with the 1. Negative 1 times 6p becomes negative 6p. And then we have negative 1 times negative 1, which then turns out to be positive 1. Now, following our foiling, we have it expanded. We can combine these two like terms right here, which are negative 6p and negative 6p. That turns into 36p squared, and then we have minus 12p, and then we have plus 1. And there's our final answer. So it's really not that much different than the other one, except for the fact that a couple of your terms are going to turn out negative, and you will need to combine them. So the last one of these I'm going to show you is this 3c minus 4, the quantity squared. Once again, we will expand this first. 3c minus 4 times 3c minus 4. Once it's expanded, we can proceed to FOIL it. 3c times 3c is 9c squared. 3c times negative 4 is negative 12c. Then we have negative 4 times 3c, which is negative 12c again. And then negative 4 times negative 4, which is positive 16. Now that we've had it totally expanded, we can add up our like terms. So we have the 9c squared drops. Then we have minus 12c, which gives me negative 24c. And then we have plus 16. And there's our final answer. Okay, now the last thing I'm going to show you is what happens when you have a product of a sum and difference. Now, this is a little bit different than the last two. If you noticed in the first one and the second one, when you FOILed them out, you always ended up with two terms in the center that were the same. So you can see the first one, there was 32c and 32c and 12t and 12t. And there's a reason why that happens. In the difference, you had a negative 6p, and then in this last one, you had negative 12c and negative 12c. The reason why those terms end up being the same is because what you're multiplying together are both the same expression. Now, because both of the signs were the same in those expressions, you had a negative here and a negative here, you had a negative here and a negative here, then those two center terms combine and create a new term. Now, what's going to happen in these is these expressions are exactly the same. We have 7q and an 8, except their signs are different. Okay, you have a minus there and a plus there. Now, these are actually called conjugates because the sign is opposite. I'm not going to get into that too much other than to tell you that when the expressions are the same except for the sign, it's going to actually cancel some terms out. So let me show you. So if I go ahead and FOIL this out, 7q times 7q, I get 49q squared. Then I take 7q times 8, which is positive 56q. Now I'm taking this negative 8 and distributing it to the 7q, and I get negative 56q. And lastly, I take the negative 8 and I multiply by positive 8, and I get negative 64. So you can see it's a little different in the way the signs worked out too. But the important thing to notice is that we do still have like terms in the center, but those like terms are opposites. So those two will actually cancel. 56q minus 56q is 0. These go away, and you're just left with 49q q squared minus 64. So you see this expression actually condenses down a little bit. The whole reason why these center terms cancel is because of the opposite signs in what we are foiling together. So let's try another one. I'll show you how that one works. Same as the last one. X times x becomes x squared. X times negative 9 is negative 9x. Then we have 9 times x, which is positive 9x. And then we have 9 times negative 9, which is negative 81. Now, once again, we have these two center terms that are like terms, but just like the previous problem that I showed you, because they are conjugates, those two center terms will cancel. The negative 9x and the 9x cancel out, and we're just left with x squared minus 81. And there's your final answer. So that's what I have for you today. Thanks for listening. As always, if you have any questions, feel free to email me. Have a great day.